Just made sure my microphone was on there, grade 8. Here we go. We are going to look at the volume and surface area of a sphere. So someone's done all the homework. And so when we look at the volume of a cylinder, we've learned that it is, so a cylinder, hopefully I spelled that right. Yes, I have. A cylinder, the volume is pi r squared times height. And the reason I put this little diagram here beside you is if you were actually, and it shows it on the top of page 732, if you were actually to put a sphere into a cylinder, your cylinder would have to have the same height as diameter, right? Because that sphere is round, it has to fit in there, right? So somebody figured this out, that if you actually look at the volume of that cylinder and you go pi r squared, and then this r squared would actually be 2 r's over here for height, right? So what they figured is it's really times 2r, right? So that volume of the cylinder, then you can figure out that it's actually 2 pi, 2 pi r3. That's really how it would work, right? So if you wrote it that way, for this is for a cylinder that has the same diameter and the same height. That's the only one way it would work for that. For the rest, we'd have to go with this formula here. So what they've done since then is figured out that if you actually pour fluid in here, that there's one third left over. This here, this ball only takes up 1/3 of that cylinder. So that means that the volume would be 2/3 times 2 pi r3. So really, the short answer there, grade 8, is that the formula for the volume of a sphere is this. Volume of a sphere. Okay, the second thing that we have to work at is surface area of a sphere, and that is slightly different. So the surface area of a sphere would be 4 pi r squared. So that's surface area. Of a sphere is 4 pi r squared. So let us go to our work that we have here. And it's got a picture there. It says, what fraction of the volume of the cylinder containing the sphere is occupied by the volume of the sphere? We talked about that already for A, in that the ball takes 2/3 of the, and what would be full of packing material, well, that's easier to figure out. It's 1/3 of it will be full of packing material. All right, and then here we have two spheres for C and D. C, it says volume and surface area of each. So our first one here has a beautiful sphere, and it is 6 inches in diameter. And it says leave pi as pi. So our volume, remember, is 4/3 pi r cubed. So really, I like to make it a little easier. If we make it 4/3 pi, and that's 3 cubed, which is 27. Right, so we can go here and cross that out, right, because this would become 1 and this would become 9. So our volume really is 36 pi. All right, and then the area, that's inches cubed. The area is 4 pi r squared. So our area again would be 4 times pi times 3 squared, which is again 36 pi inches squared. D, we have another one as well. So D talks about having a circle as well, and our diameter, come on, is 30. So if we look at our diameter is 30, let's work that out again. So the volume equals 4/3 pi r cubed. So that again would be 4/3 pi, and we have to use 3.14 for pi. We'll leave that there for now. And then it would be 15 cubed. So, pulling up our handy dandy calculator, we go 15 times 15 times 15 times 3.14 times 4 divided by 3, and there we get our number, 14,130 centimeter cubed. So volume equals 14,130 centimeter cubed. Same thing with area, is 4 pi r squared. Area again, 4 times 3.14 times 15 squared. You do your math again. 4 times 3.14 times 15 times 15. And then we get our answer, 2826. So area equals 2826 centimeters squared. So that's how you figure it out for surface area and volume of a sphere. So you'll see that when you do the first one, you're going to have repeat questions there. So do the odd questions. If you have any questions, send them my way. I'll be on Meet.